accumulation point, or another word, another term for this is cluster point. So the definition we're looking at is of the accumulation point or cluster point, not of a sequence, but of a infinite set. Okay. All right, of the real numbers, infinite set of a real number. So what do I want to do? Well, I want to write, oh yeah, I want to, before we even do anything, I'm going to give you the formula for that. When you figure out that there is a cluster point, it looks like this. So this guy here in red is the cluster point. And then S are the elements of the set. So it's it resembles the same thing, except I don't know why they used X, but they went ahead and the book does it. So, and it is it epsilon? Yes. I was like, it should be delta, but it isn't. And that's fine. Okay. So, and it should remind you of this guy here, right? So this is the second half of the limit for, right? So it goes like this. If should I do C and then greater than 0 and less than delta, and this should be A, sorry. Yeah, let's go with A. So if this is the case, then so this thing is on here. So this is for functions. So all I'm doing is this part looks like that. Should I do the function bit too, or a review, or no? I think we don't. It's fine, right? So anyways, the formalization of the cluster point idea is this right here, and it looks like the second half. And f of x is the one that is the one that this is fixed, and this is the one that moves. So over here, this is the fixed point, even though it says x. Okay, and then this guy here is this is S elements of the infinite set S of reals. Okay, so I'm going to So I'm going to delete this, and right below it, let's draw a little picture before I write down the definition. So we have this is the fixed point. This is the point that moves. So these are the S's on both sides of the cluster point, right? This is the cluster point. So in other words, so you can express this like this, which means that we are here and X is in the middle, and this is R, and then actually So this is S, the set. And then, so if we go back, so all the S's are within delta distance of X, as in del. No, why did I say delta? Sorry, epsilon. Oh, okay. I'm like, where is, no, there's no delta. I'm like, why am I? Yeah, I think I had too much food. So, epsilon. And let S be a subset of R, real numbers. Okay, so cluster point in a, so this is S is a subset of R. As soon as you say that, it's obvious that it's going to be, maybe you'll draw the pictures. I'll draw one picture here and then you'll modify it. So we got this, and we got this. And the thing that I was having trouble with, we'll do the reverse of it, by the way. So this is S. Is there anything else that this, and then I think we need to make this. Okay, so the first line of the definition says that let S be a subset of R, and we have drawn it. Then he says a point, then the definition says a point X in R is an accumulation point or cluster point of S. So, and it's a cluster point of S, which means it's a cluster point of S means that X is in S, right? Even though a point X in R, but it's a cluster point of S. So, is it? Well, I'm kind of going with that. And I'm going, okay, so I had some trouble with this because initially when I read this and it just said in R, I put my X here, which makes no sense because it is the points of this, the lowercase s that cluster around X. And if X is not in S, that because the whole cluster point is cluster point of the set S, cluster point of point X in S is an accumulation point of S. It would sound really crazy. Yeah, that's what they wanted to say. X is real, and it is an accumulation point or cluster point of S or in S. So anyway, so we're gonna, because of this whole thing, I'm using this color, and I'm going to put it right here in the middle. No, actually, sorry. Where did I put it? I did put it right in the middle. Okay, and X. And as I'm for every epsilon. So the whole idea of cluster point is you have X here, and this is your set, let's say your set S, and all the, there were some S here, and then there were finitely many, few here, finitely few here, and then all of a sudden, they started to jam up and fall on either side. And maybe there was one here, just like in our sequence with the limit, and we did all this, how they all cluster and all that. And the limit was A, if you remember. So it's the same idea. And so let's see, let's keep it there. And here we have the finitely, infinitely many. It's the infinitely many that cluster around X. Okay, so and at this distance, right? Epsilon. So if for every epsilon greater than 0, as in epsilon is a positive, for every small, tiny epsilon or big positive number, there is a point S in S with S not equal to X. So I'm going to move our little S here to kind of like down here, as in to the side, make this slightly bigger. And so now it says, yeah, so my diagram is wrong in the book. I mean, not in the book, in my PowerPoint. So here we have, let's put in the epsilon. So X minus epsilon and X plus epsilon. Yeah, and then I think for infinite number, I'm going to go like this. We got a jungle. This is infinite. Infinite S's. All within. Look at the, yeah, that does look good. Okay. So I'm going to put in here our key. Infinitely many. And this is, and if it's just this, finitely few. Okay, so it continues, and we're going to get that basically this picture formalized, right? And the formalization is 0. We have all the elements of set S, infinitely many elements of set S, and this is lowercase s, are all within the distance of epsilon from X. This is our cluster point. These are the elements, infinitely many elements of set S. So this is the point, the points S, and S is never equal to cluster point. And how do we say that? Like this. So this part here, the underlined part says S not equal to the cluster point X, which is this. This condition comes in when we add that.